Hello, everyone. My name is Arnima Chaudhary, and this is the third week of the Women in Ethereum Protocol Study Group. And today we have Matthew with us from the Lodestar team. Yeah, hi. And he will be giving us an introduction and then a deep dive into the consensus layer things. So, welcome, Matthew. The stage is yours. You can start introducing yourself and then the presentation, whatever you want. Yours.
Thanks. Hello. Hi, everybody. My name is Matt. I am a little bit about me is my background. I am absolutely a crypto evangelist. My very first career was real estate development and did construction. So building buildings. And so programming is my second career. So I'll get that out there first. If this is something that is new to you, or if this is something that is a change for you, it's very possible because I've done that. Like I did something very different was my first career. And once I found crypto, and I'm very much a crypto evangelist, I believe in it from a philosophical perspective, that it is a profoundly important technology that I think is a very important tool to break the incumbency of wealth and power in the world today. It's one of the big things that all of us struggle underneath, no matter where you're from. Being part of this very big tent that comes together to create the Ethereum protocol is just a humbling and invigorating experience. It is absolutely something that if you believe that you can do it or you want to do it, there's absolutely a place for you in order to make those steps towards your goal. This is something that I have a lot of passion for. And so I've been in the Ethereum space I've been working on the Lodestar team almost 3 years now. Before that, I did a lot of other Web3 based companies, and then before that I did regular tech, so like Web2 cloud migrations and some digital wallet as far as like Google Pass and Apple Pay. So a little bit of my background, but again, programming is my second career. So it's one of those things that there is absolutely a path to migrate into this space if it's something that you really have passion for, because I'm not going to lie, it's complicated, and it does require a deep focus and a deep commitment to really be able to carry yourself across the finish line with learning these protocols. So the first thing I'd like to talk about, and because of this, the idea of these protocols, we'll talk first about encoding some protocols. So Ethereum is a protocol first and foremost. Like, it is a blockchain, and it is something that gives you the ability to do this value transfer or value representation in the digital world. But really what makes it work is the ideas of protocols. And I work on the consensus side. So Ethereum is broken into a couple pieces. And if you're going to turn on an Ethereum node, so you're turning on Ethereum, I want to start Ethereum, what you're really doing is you're starting a couple pieces of software. So the first piece of software you're going to start is an execution node. And that is like when you think of proof of work back in the day, and we're going to talk about this in a second because I'm not exactly sure where everybody's baseline is. I'll try to go as deep as I need to in order to bring everybody up to speed. So first and foremost, if anybody has any questions, or I'm going too fast, or if you want some more clarity, please feel free to use the raise your hand, and I'll be happy in order to either address your questions, or we'll go from there. On this idea of protocols, you're starting up an Ethereum node. You're going to be starting an execution client. Execution clients are Geth, it's Bezu, it's Nethermind, and there's several others. And then the second piece of software you're going to start is a beacon node. And a beacon node is what does the proof of stake consensus algorithm. So like we are Lodestar, we are doing this proof of stake protocol. The other big ones are Lighthouse, Prism, Teku, Nimbus. There's a whole lot of them. Grandine is one of the newer ones that came in. And then there's this whole discussion about the Beam chain that's now lean Ethereum. It's another discussion, but again, that's consensus. The idea of, get there. And then the third piece of software you're going to start is a validator. So again, if you're really starting an Ethereum node, what you're going to be doing is you're going to be starting an execution layer, a consensus layer, and a validator layer. So it's three pieces of software that really work together in order to be able to create what it is that we call Ethereum. And we're going to focus a little bit on the consensus today. That's why I'm here with you guys today. Do you mind? Thank you. Okay, so consensus is, first I'm going to ask you, please, I want somebody out there in the audience, I would love you guys, somebody raise your hand, what is consensus? Like if you were to use a definition of consensus, what is consensus? Don't be shy, come on.
I think consensus, just for the word, is like there is people that has to agree on something.
Okay, great answer. Who else has a definition of consensus? Celia, go ahead.
Okay, so it's also like having a mutual understanding to do something together.
Perfect. And this is what consensus layer does. So when I say the consensus layer, what I'm talking about is the beacon chain. So, but what are we coming to consensus on? And this is the idea of consensus algorithms or consensus protocols. The two big ones being proof of work and proof of stake. And what these algorithms do is you're coming to consensus or agreeing on what is the state of the application right now. And what do I mean by that? So we'll start with Bitcoin because it is the only real proof of work chain left. And as a note, when I say the execution layer of Ethereum, before we did the merge, before the beacon nodes, the consensus layer happened, Ethereum did proof of work. So Ethereum was a proof of work consensus algorithm blockchain. And that was the very first implementation of Ethereum. Okay, so what proof of work is it is a way that you have in these distributed systems, and this is the most important thing, is when you talk about decentralization. Decentralization means I can turn my computer on and I can start the Ethereum protocol, or I can start the Bitcoin protocol, or I can start the Solana protocol, right? And I'm going to turn on my computer and I want to join this network. So I am a decentralized node. I am one of the participants in this network, and I am going to join in to creating or to managing the application state. And in the case of Bitcoin, the application state is how much Bitcoin is in each wallet. All right. It is the simplest of all of the blockchains because it was the first. And really all it concerned with is at this address. So at address 1234, there is 1.75 Bitcoin. And at address 2563, there's 0.001 Bitcoin in that address. That is the application state when we talk about we're coming to consensus on what is the value in every wallet on the Bitcoin network. All right. And they use the proof of work application or consensus algorithm so that all of the nodes, everybody who's turned on a Bitcoin application, they are going to be storing in their database how much money is in each wallet, how much Bitcoin is in each wallet. And so coming to consensus on my computer says wallet 1234 has 1.75, but your computer, because a transaction may have been seen by your computer. So like say I have a computer, I'm in Bangkok in Thailand, and somebody else has a computer that's in Santiago, Chile. We are very, very far apart when it comes to the global distribution network for fiber optic cables. And it takes about 400 milliseconds, 300 milliseconds, roughly 0.3 seconds for speed of light to get my transaction from Bangkok to Chile. So all the way, or to Europe, all right? So if I wanted to literally use a lightning beam and I want to send my transaction across the world, it takes some amount of time for that information to propagate to the other side of the world. So I will see the transaction and I'll say, okay, somebody spent money out of this account. They wanted to spend 0.25 Bitcoin. So I had it as 1.75. I'm going to move that 0.25 to the wallet that they wanted to go to. All right. But now it takes half a second for that to actually, that information to make it to Europe or to make it to South America. And so they will see on their database and in their application, they will see that address 1234 has 1.75 Bitcoin still, right? Like it just, they haven't had the time in order to be able to see that that change comes. All right. And this is the whole heart of what consensus does, is this distributed, the solving of decentralization and distributed information propagation and storage is very, very, very complicated. It actually started way beforehand with databases more than with blockchain. So blockchain is just, we've created novel ways of coming to consensus about what the truth is. That doesn't change the fact that like we're still solving the same problem that SQL had to solve a very long time ago. Is if you have like, say for instance, I've got a banking application or I've got Facebook. So like I go and I send my Facebook Messenger message to the server. I am now going to have to write that information to my server, and then that has to be seen by my friends around the world. And like being able to come to consensus on what is the state of the application, meaning what messages have been sent, what transactions have been created, what smart contracts have been deployed, is the heart of what consensus does. All right, so like to bring it into focus of what Web3 does is exactly what the two people who provided those explanations or those definitions is agreeing on what is the truth, or agreeing on what it is that we are all working together to do. So proof of stake is a consensus algorithm that was invented by Ethereum. Actually, I think it was first invented by Ethereum. I apologize, we may have to do some research on that. But the truth is that most blockchains in the world today implement proof of stake. And proof of stake is fundamentally different than what proof of work does. We won't talk about proof of work. If you want, that's a very interesting topic. It's something that I'm very passionate about, is how Bitcoin works. It's also how Ethereum worked before we did the merge. And when I say the merge is, we have, back to that, you start an execution client, you start a consensus client, you start a validator client. The proof of work was just the execution client. And what Ethereum did in the merge is we created a second chain. It's not exactly the second chain, all right? And we'll get to some of these details. This starts to get into the weeds of how the protocol actually works. But a blockchain is, and actually, let me ask a quick question. Who here knows what hashing is? Okay, I see one hand. Does anybody? Do we have broad leg? Yeah, great. Hands. Everybody show. How many hands? Please raise your hand if you know what hashing is. We've got 4, 5, 6, 7. Okay, great. So about half of you know what hashing is. All right. And now, when you create a block in a blockchain, what you're going to do is you're going to hash the data in that block. And what does that mean is, for the other half of you, hashing is one of these fundamentally critical primitives that we use in blockchain. And it's a hashing algorithm was invented for databases. So when you look at a database, it's like in those, back in the day, the hard drives were like platters of data. They were like these metal spinning disks that with these read heads that would like write the data to this spinning metal disk. And they're very, very fast when you store the data at the very middle, because the angular velocity at the center of the disk is much, much higher than it is at the very outside of the disk. So like it's much faster to find and write and read data from the center of the hard drive than it is from the outside of the hard drive. So you don't really want to start storing data at the middle, and just as the hard drive, as your database fills up and as you add more data to your database, like it just slowly moves the data towards the outside of the platter, because you're now going to have these incredibly bad irregularities with how fast and how quickly you read and write data for different, depending on how old the data is. So what they did is they created a way that you can store the data evenly across this spinning platter of metal. And this is where hashing really started. So there are other reasons why it's used, but for the most part, it's called a hash table, where you input some data and you get a hash value out of it. So if I were to store a point, like I'm going to use a hashing algorithms are like SHA-256 or Keshak, or there's a lot of them. It's outside the scope of the discussion, but these are algorithms where for every input that you give to the hashing algorithm, you get a unique output out. Meaning if I'm just going to hash a period, one single point, the output of that hash function is going to be the same length. So it's going to be 32 bytes long or 64 bytes long or 256 bytes long, and it's going to be unique. And if I was going to add, if I'm going to hash War and Peace, it's this. If anybody knows this, it's a book. War and Peace is like 10,000 pages long or some crazy long book. All right. So if you're going to hash War and Peace, you're still going to get 32 characters out of a 32-bit hash, but it's going to be a different 32 characters. And if you were to take it's the best of times, it was the worst of times, and you switch those around. So now it said it's the worst of times, it was the best of times. But the rest of the book is the same. You will get a different hash. And the idea of this is that for any input you give into a hash function, the output is going to be unique. And if you do not get something different for every single input, it's called a hash collision. These are very bad. It's one of the fundamental properties of a good hashing algorithm is that for every input you give, meaning you give War and Peace with an exclamation at the last, literally you change one character and you get a different hash value out of that hash algorithm. All right. This is a fundamental primitive when it comes to blockchain technology, because what we do is a block. When you say a block in a blockchain, what makes a block is it's a bit of data. It has the time it was created. It has who was the creator of it. It has what transactions were in that block, but it's literally a JSON object. It's an object with some values and some data on it. And you now hash that object and you get a unique value out of it. And now, in order to, yep, and the nonce exactly would also go into that value. So now if you were to take a block and you were to change just the nonce, the hash value for that block changes. And this is what makes the indelible record when it comes to a blockchain, is that I have a block and I'm going to hash that block. And now I'm going to store that root, all right, on the next block. So one of the fields of every block is the parent block, parent root. And so in the case of Ethereum proof of work, you had an execution layer block, and that execution layer block had a list of transactions in it, has a list of withdrawals, a list of deposits. It has some information, meta about it, like who produced it, and it will have what was the one that came before it, what was the parent block that is directly before the block we just created. So I'm going to now hash the parent block, and I'm going to put that field, like that value, in the field of the next block. And then we're going to make a new block after that. And we're going to now hash the one that came before it, the one we just created. And that becomes the parent of the next block. And now the next block, you hash that one, and that becomes the parent of this next block ahead of it. And here's the funny thing about it is, you now have this chain of blocks, all right? And if we were to change the transaction way down here, 10 blocks back, if we were going to change one of those transactions, it would change the hash of that block 10 blocks back. But it will also change the hash of every block that comes after it. Because if we change the hash of the block that was at 10 blocks back, and now that parent hash is stored on the block 9 blocks back, and that is stored in the parent hash of 8 blocks back, and that is stored in the hash of 7 blocks back, and so on and so forth. You've now changed the hash of every block that comes after it. And this is where part of the indelible security of blockchain comes in, is that once you've hashed the prior block, everything that came before that is indelibly locked or stored in that hash. There's a memory so that you can never change anything else that came before it. Now, when we did the merge and we created the consensus layer, what we did was we created a second chain of blocks. So proof of work has a set of blocks that have this parent root. It's the execution block parent root that has the information for all of the transactions. Yes, thank you. I hope, and I'm going to go very fast. So I know this is being recorded. Please feel free, come back and ask me. I'll give you my Discord information when we get to the end. I love talking about this stuff. I'll be happy to do it again. But watch this video. It's going to be very dense. There's a lot here. And again, when we get to the end, I'm going to do some questions and answers. So write your questions down and we'll come back to, I'll try to address everything. Okay, so now when we came, yeah, great, please do it. So now we did the merge. What is the merge? The merge created the beacon chain. The beacon chain is the consensus chain now. So when I said there's sort of two chains, it's sort of true. It's not exactly true because one chain points directly at the other chain. So like the execution layer has no knowledge of the consensus layer because it's backwards compatible. The execution layer is just solely concerned with building blocks that have to do with transactions and the state of the Ethereum application. So when I say the state of the Ethereum application, that means that I have an Ethereum address. My Ethereum address has 2.7 Ethereum in it, or I've deployed a smart contract that's at this address, and there is some data and contract code that's tied to an address. All right, this is all stored on the execution. So the idea of how much is in an account, what smart contracts are at an address, sending transactions in order to do some stuff, meaning I'm going to mint a coin, I'm going to do some DeFi, I'm going to create an ENS name. All of that is concerned with sending the execution layer a transaction. And the execution layer will do the state transition between adding that transaction to the state, and then that state representation is added to the block. And so like you have execution state, execution blocks, and those execution blocks create that chain of blocks that I was talking about before. But now, when you get to consensus, consensus is fundamentally different. Consensus is totally concerned with what is the last execution block. So we have what's called the consensus state, all right? And the beacon chain is a separate blockchain that directly correlates with blocks on the execution chain. And this is how we accomplish the merge, is the execution layer is fundamentally isolated and has no knowledge of the consensus layer, but the consensus layer is now in the driver's seat. So when we did the merge, what we did is we stood a second chain, the consensus chain, the beacon chain, if you've heard that before. The beacon chain is a separate set of blocks that have that same parent root on it. So the idea is you have a beacon block that's at slot 1, 2, 3, 4. Well, let's use a different one because we did 1, 2, 3, 4, 4. Okay, so now you have slot 2, 3, 4, 5. I'm very creative, I know. Okay, so 2, 3, 4, 5 is going to be a beacon block. And that beacon block is going to have a parent root of what was in 2, 3, 4, 4, right? So like the parent root of the consensus block that came before it, but it is also going to have the root of the execution block that is at that slot. So execution blocks used to come every 12 seconds. And what the beacon chain does is, or about every 10 to 12 seconds, because it was proof of work. It wasn't exactly, all right? But what the beacon chain did was it created this idea of slots. A slot is a place where you can have a block. It's a 12-second period of time where you assume that there's going to be an execution block that happens within that slot. So at 2, 3, 4, 5, there is a beacon block, and that beacon block has on it one of the fields that says it was execution block 5, 6, 7, 8, 9, 10. All right. And it basically directly references the block at the execution layer that happened at that 12-second period of time. And it also does this very fancy thing of doing that, has a parent root that came from block 2, 3, 4, 4. And block 2, 3, 5, 6 is going to, or 2, 3, 5, 7 is going to have 2, 3, 4, whatever, you know what I mean. Okay, so the one after is going to have a parent root for the one before, and the one after that is going to have a parent root of the one before it. So like you now have these two chains of blocks that are linked by parent roots and have a link between them from the CL side to the EL side. All right, and it was done in steps. And the steps that really happened is we started the beacon chain, that was phase 0. We added some other stuff, that was Altair. Bellatrix is when we really switched over to doing execution, is the merge. All right, so now, is it Capella? No, it was Bellatrix. Yeah, it was Bellatrix. Okay, so now the way it works is, it used to be an execution layer, like an execution node would build a block and announce that it has a block because it did the proof of work protocol, and it basically got the mining reward for building the block that extended the execution chain. And now we've switched over to validator rewards. So what is a validator? And remember when I said, when you start an Ethereum node, you've got 3 different pieces of software. You're starting an execution layer, you're starting a beacon layer, a consensus client, and you're starting a validator client. What a validator client is, I vote that is the current head. And head is what we use as a very important term of what is that the tip of the chain. Like, it is the most recent block that was created, has a proper terminology name of the head block. All right. And then the block that comes after that becomes the new head once that one has been superseded, once the next one in the chain is created. All right. And what you vote on is, what is the head? And again, what are you really voting on is my view of account address 1234 in that original example. When I'm in Thailand and Europe is half a second away from me by light speed. So like, I now have I see a transaction that says I want to send 0.25 Ethereum to somebody else. So like, I will see that transaction and I will deduct 0.25 on my computer from here in order to put it in the other one. But it may take time for Europe to see that transaction. And this is the whole thing about coming to consensus across distributed networks, is we all vote on it. So like, I will basically say, and it's not exactly that I see a transaction and I add it. What I'm really going to say is, because consensus is, see a block that was produced. So someone has created a new block, and I say my view of the network is that the current head block is 2, 3, 4, 5. Like, that's the one I saw come across my network interface card. So my NIC basically delivered me that information. But now in Europe, it takes time for that block to propagate across the network. Someone creates this block, they sign it, and then send it across the network. And they may have been sitting in, say, the Philippines, which is geographically very close to me. So I'm going to see that block first. And then I'm going to relay it to everybody else that sits next to me, like everybody else that's connected to my node. I'm going to send them that same block. And they're going to do the same thing. They are now going to see that block and say, okay, that's the source of truth for what the application state is right this second. And they will then forward it on to all of their peers, and so on and so forth. So maybe they have a peer, I have a peer that's in, say, India, and they have a peer that's in, say, South Africa, and they have a peer that's in, say, Saudi Arabia, and they have a peer that's in, say, Germany. Now, that block had to go between 5 or 6 computers in order to get to Germany. And now Germany sees it a half a second or a second later, and they can now vote on what they see as the head block. So they see this block, and this is where the idea of consensus protocol comes in. The consensus algorithm, proof of stake, says that I am going to vote on a block 4 seconds into the slot. So like, I have up to 4 seconds. So like, remember, there is these 12-second chunks of time where a block happens. This is a slot. And if I see a block within the first 4 seconds of that period of time, I am now going to validate that I see that block. So my validator, and this is what the validator client does, is the validator client, every time I see a new block, I'm going to sign over a piece of information that basically says, I certify I have seen that block, and I am validating that that is my view of the chain at this particular time. All right. Now, say, for instance, someone is in Iceland. So it's another hop away from Germany, or maybe 2 hops away from Germany, and they do not see that block yet. So we get to the 4-second time window, and they do not see a block, the same block that I saw, that we saw in India, that saw in South Africa, that they saw in Saudi Arabia, that they saw in Germany, but it doesn't have time to get all the way to Iceland. Now, the person who's sitting in Iceland will vote and say, my current head at 4 seconds was the one before it. Like, they're basically voting that the source of truth is the one from before. It's called a skip slot. Like, I did not see a block in time in order for me to sign over certification that I know what the tip of the chain is. So now my vote is for 1 slot back. All right. And now this is how the proof of stake algorithm comes to be, is that in order for me, in order to sign over these attestations that something is true, I have to put my money on the table. It's the idea of put your money where your mouth is. You want to bet on something or you want to be able to participate in something, you have to put you have to put something on the line for in case you do something wrong, you can be penalized. And that's the whole point of proof of stake is that I'm going to start a validator. In order for me to do a validator, I have to put 32 ETH on the line, which is quite a bit of money in today's terms. So there are ways to do sharding and distributed validation, and like we're working very hard in order to bring that threshold down so that we can bring more people into the fold. But when this algorithm was created, 32 ETH was not a lot of money. It was $1,000, $2,000. It is now 120 some thousand dollars, 100, so it's quite a bit more. And this is the thing is that I've got money on the table. I've put my money where my mouth is. So if I'm going to be voting on what is the current head, like where are we as a network? If I lie, if I make a mistake, but really the big thing is lying, I'm going to have some of my money taken away. I am going to be penalized. It's called slashing. And there are some of these slashable offenses that come in where I have openly lied. Somebody else caught me as openly lying because again, it's all publicly accessible information. This is what the blockchain does is we put everything out there in the open and give everybody the chance to audit it. And if someone figures it out, like not everybody gets slashed just because they lied, but there are people who are literally paid, like they've built applications in order to look for this. And they're basically looking for it because if they catch me in a lie and they submit that they caught me in a lie and it's true, they get the reward. So now my motivation in order to make sure that my node is very well connected, meaning that I'm not sitting so far away from the network, like I'm not sitting in the middle of the South Pacific in Tahiti where I have a terrible internet connection. I want to probably co-locate my connection in New York or Berlin or Bangkok or Singapore, or because it's in my best interest to be as well connected to the network as I can. This is a slight example. We actually have somebody on our team that lives in Madeira. Madeira is an island off the coast of Africa and Europe. And he runs a validator and he has 99.9% effectiveness. So like there is a lot of flexibility in the protocol. And one of the things that we do is make sure that the protocol is flexible enough that anybody can participate. But we want to make sure that everybody knows what is the state of the application. So what is the validator doing? The validator is saying that I have thoroughly vetted and checked the block that just came across in a slot. And I've signed and certified that that block is valid and current. And then everybody that's paying attention to the network does that exact same thing. So now you have a way you can aggregate, and that's what we really do is we aggregate the attestations is even what we call it. We're going to aggregate those attestations and pack them into the next block. So now you have an on-chain record of what everybody voted for. So you now can go back and audit who voted, how did they vote? Did they vote for the current head? Was their vote late? Was there, so you could do a lot of metrics and telemetry to kind of understand how the network is, how healthy the network is and how it's functioning. All right. And this is, as you can tell, a very, very complex system. Like I've been rambling for 15 minutes and I haven't even touched on anything really important. We're just talking about the philosophical stuff. All right. So in order to really understand this, and mind you, I've been doing it for 3 years. Okay. Like I've been doing this for a while. When I started, I got my start working for the Lodestar team because I know a lot about Node.js internals. Like we are a JavaScript client that runs on Node. And I know a lot of native layer code. And I also understand some of the fundamentals of how Node and the virtual machine for JavaScript run at a very deep level. And I knew nothing about anything I just told you. I did not know that there was a beacon chain. When I met the Lodestar team, I knew what proof of work was. I knew what Ethereum was, but I did not know there was a beacon chain. I did not know it was a second chain, and I did not know how any of this stuff worked. I had to learn that. So like, do not be overwhelmed, but it will be overwhelming. And that's okay because it's broken into a number of domains. And what do I mean by that? When you start doing protocol development, you should be overwhelmed. If you are not, you deserve to be running the thing. Like, it is a very complicated system. It's very complex, and that is totally okay. The best way to kind of like dip a toe in order to just get started is you just have to start somewhere. And this is where the idea of broken into domains matters. So there are a lot of different pieces that go into creating this application that I'm telling you about. Now, if you're more interested on the execution layer versus the consensus layer, absolutely choose an execution layer. And you're going to be looking at state transitions. You're going to be looking at opcodes. You're going to be looking at RLP. You're going to be looking at dev P2P, which is the networking layer. All right. If you're more interested in consensus and coming to consensus, which is a totally different paradigm, you're going to be looking at libp2p. You're going to be looking at BLS and signature aggregation. You're going to be looking at state transitions, which actually you do state transition in the execution layer as well. You're going to be looking at validation and validator clients. You're going to be looking at discovery, because discovery is a totally different thing. And that is really the heart of where you start. You pick one. I am really interested in networking. Not that I am. I'm a little interested in networking, but we're just saying I'm you for now. Okay, so like, I am really interested in networking. So now I'm going to start looking at the networking domain when it comes to the Ethereum protocol. And there's several different pieces of the networking domain. There is the very low level fundamentals that are integrating with the OSI model. So are we using TCP or UDP? Are we using Quick? All right. And then when you get above that, then you start looking at what is the discovery mechanism? And disk v5 is what we use in order to do discovery. And what do I mean by discovery is that I turn on my computer. I have no other computers connected to my computer, but I want to participate in an Ethereum protocol. How do I find the other computers that are on the network? Like, if it's an open network and all Ethereum computers are connected to the open internet, like, how do I start looking for which other computers I should connect to in order to participate in this wonderful thing that we call Ethereum and we call blockchain? And this is where discovery comes in, there are a list of hard-coded, we like bake a couple servers or a couple addresses in, and you now connect to them, and they give you a list of other people that participate that are connected to them. Like, they are basically serving up addresses of people that you can talk to. And it's basically, it's called an ENR, but it's more or less, it's an IP address. It's like, you can dial this address and you will get an Ethereum node. And then you will dial that address, and they will give you another list of people that you can dial. So now you can walk, which is called this distributed hash table or distributed graph of nodes that are interconnected to each other in order to be able to eventually walk through all of the different nodes to find other people to connect to. This is the idea of discovery, all right? But it is one of the small subdomains of the broader networking domain that happens when you start a node. So like, I'm now really interested in networking, but discovery doesn't really, it just seems a little complicated. I don't know, I don't want to do that. Okay, so now there is the idea of gossip sub, and there's the idea of RecResp, two other completely separate domains of networking. And there are these fundamental things that we do as a node. We are pushing data that comes across our network. So like, we are connected to a number of other computers that are running a beacon node. And again, I'm just going to be focusing on the beacon chain and the consensus clients right now. It's what I do. There will be other people that you're going to speak to in the future. There will be other people in the future that will talk to you specifically about the execution layer. But right now, we're just going to talk about the consensus layer. So now I am connected to a number of other computers that are on this beacon chain. And one of the things we do in order, and one of the things that's critically important for distributed systems is push and pull of data. So like, I am going to be connected to a bunch of people, and they're going to be pushing me data. They're going to be sending me the block that they saw. So remember in that example that I said, I saw a block here. I pushed it to another computer that was based in India. They pushed it to another computer that was based in South America or South Africa. They pushed it to another person in Saudi Arabia. They pushed it to another person in Germany. All right. This is the way it works. It's like, somebody pushed it to me and I validated it. And now I'm going to push it to everybody else I'm connected to. So if I'm connected to, say, roughly most nodes today connect to about 200 other nodes. So I turn on my computer, I'm going to connect to 200 other computers that are doing the same thing as me. And they're going to be sending me information. And everything they push to me, I'm going to validate and then re-push out to the next step. And that's how the data kind of hops between all of the computers in order to get all the way around the world. And there's about 10,000 computers, and you could do an N of P. I forgot whatever. It's about 10 hops. So like 10, 12 hops, you should be able to get data to every node on the network. All right. And that is Gossip Sub. So Gossip Sub lives on top of the libp2p protocol. libp2p was originally designed for Filecoin, but is the fundamental basis that an awful lot of systems use today. It's kind of similar to torrent, like BitTorrent, if you guys have ever used BitTorrent before. All right, so like a lot of these decentralized protocols, when it comes to the networking protocols, are very similar, but a little different. And so we happen to use the libp2p specification and that protocol. And we built Gossip Sub on top of it, which is an implementation of libp2p that also uses a muxer. And I digress. It's about multi-threading and multi-channel communication, rather. Okay, so now that is how data is pushed through the network. Is I'm connected to a bunch of people. Somebody has basically pub subbed me, and I'm going to turn around and publish it back out to everybody else. And then, well, now what happens if? Yeah, I love that. I grew up with BitTorrent too. I'm freaking old. So I'm 43, by the way. I know I've got a lot of energy, and I don't seem like I'm spry. I'm just very excited about this stuff.
Sorry to interrupt. And
Yes.
just one thing, like a question that we have been getting even in the first session a lot. So many of the participants here are not from a tech background. So there are some from other backgrounds, and even you are from a different background. So someone who is just starting with the protocol, what's the best piece from the protocol to pick up and get started as a beginner? Would you like to share something on that, a few words on that?
This is a very personal question. Like, it depends, what do you like? And that is also a very personal thing. Like, not everybody is super excited about the OSI model. I can tell you I am not. Like, I did not start doing the OSI stuff, like this networking layer. I was more interested in performance applications, and I was also focused on the actual, yes, I am, and proud. I nerd hard. So I was very interested in the actual crypto. So when I started, I was curious about, because we were having a performance bottleneck. Remember, I told you that I'm very familiar with the node internals. And when you get to about 70% of the work that the CPU does when running an Ethereum application is cryptography. It's mathematics. It's literally the crypto in cryptocurrency. And cryptography is what makes the digital world go around. So if you think about HTTP versus HTTPS, that little S is SSL/TLS, is cryptography. Or when you think about on your phone, fully encrypted end-to-end, which is what WhatsApp says or Signal says or Telegram says, you're using PGP most of the time, pretty good privacy, which is an asymmetric cryptographic paradigm in order to be able to secure communications between two parties. But again, the cryptography that does that, the HTTPS or your end-to-end PGP, is the same exact cryptography that we use in cryptocurrency. So, right? So like, I was interested in that stuff. I came from a background of mathematics. I like it. So like, I started doing BLS and doing the crypto optimizations as far as like performance optimizations of implementation of the cryptography. Cayman on our team is very, very deeply integrated with the networking. He just loves networking. He geeks out on it. He loves the OSI model. He loves the ideas of all these protocols and encodings. And that was something that was interesting to him. So he chose that. And this is why I say it's a very personal question of what you want to pick up first, which is why I started by saying that there are many domains. Like if you're interested in state transition is, how do we go from one block to the next block? So state is the underlying state of the application. It is, where are we right now in memory? All right. And then the inputs to a state transition function are your previous state and your block, and you get a post state. So pre-state plus a block, You do the state transition in order to incorporate that block into the state, and you get a post state. All right. And then that post state becomes the pre-state for the next block that you do a state transition on. And state transition is another domain within this. There's a whole nother domain of validators. If you're very interested in the idea of validator economics and how to actually do validations or how to do operations as someone who's a large node operator, these are all fundamentally different domains. And if you're looking to get started in this, I would suggest choose one. Either choose the state transition. Fork choice is another big thing. Fork choice is, remember when I said I'm voting on which block I see as the current head. Like I saw block 2, 3, 4, 5, but the person in Iceland did not see that. So they said current head was 2, 3, 4, 4. And now we've both attested to what we've seen as the current state of truth. And then those attestations get mushed up into what's called fork choice. And fork choice is the heart of the consensus algorithm. So if you're very interested in reading about what is fork choice and what is LMD ghost and like what is the finality gadget and understanding what is your checkpoint state, what is the checkpoint, meaning what is the last validated epoch, the slot after the last validated epoch where we have basically said history is locked. These are all it's a totally different domain when it comes to this. And this is the most important thing I can say is that you cannot learn it all at once. It is physically impossible. I've been doing it for years. I still don't know everything. And I'm proud to say that because all of us work on teams that are very, very, very tightly woven. All of the teams are very, we are incredibly tight. And we have great trust in each other because it is such a broad domain that it's very difficult to know everything. And it's also very difficult to know what things are changing right now. And this is one of those things that you will have to be comfortable with, is that this is it's just a hugely complex thing. And you should not be overwhelmed. Pick a very tiny piece. I am interested in how do attestations get aggregated. I am curious on how does the BLS library work. I am really interested in how do we do database management so that we are making the most efficient use of our disk space. I am very curious with how does validator effectiveness and efficiency get tailored or get affected by how state transitions happen. I am very interested in making the state transition as efficient as possible because it is a very time intensive and time critical process that has to happen on time. Like all of these things are like a tiny, tiny, tiny little window. And once you zoom in on that, you'll realize you'll get a little closer and you'll go, oh, wait, in state transition, we have to look at withdrawals and deposits and how are we getting withdrawals and deposits? And that is really the best advice I can give you. I can't tell you, I think you should go do networking. I can't tell you, I think you should go pick up the database because that's a very personal decision. But what I would suggest is talk to some people on the teams that you're working with. Ask them questions about what exactly they specialize in, because at least from what I've seen in all the other teams that we've worked with, is that some people tend to specialize in certain things and everybody's got the things that they are interested in. And like, what is it that like makes you happy when you work every day? And then go from there and then find the little detail in that one domain and just focus on that one detail. And then from there, you will grow and blossom because you will have to take one little piece and you'll realize that one tiny, tiny little piece grows into a little bit bigger piece, but it's only a fraction of it, but it still makes the whole. And it still affects how the rest of those pieces come together. And then you're going to zoom out a little bit more and you'll realize that that one tiny little thing that you started with affected a slightly bigger piece, and that plugged into a bigger piece, and that plugged into a bigger piece. And just don't get overwhelmed because all you really need to do is focus on that tiny, tiny little thing. And really, what does that mean? Looking at one function, looking at one part of the spec. So when you look at the specs, you realize that there are hundreds and hundreds of pages of spec. And when I tell you the spec reads like the most boring freaking thing you've ever done. It is terribly dry. It is really technical. It is extremely, like, it's very terse. And it's like a little confusing. And like, don't let that fool you or dissuade you. And I like to think I'm okay at this stuff. Like, I'm not so bad. Like, I'm pretty good. And like, I still read it and go, what the heck did that mean? Hey, Cayman, what was that again? And like, that's okay. Like, that is absolutely a normal part of the process. You just have to start somewhere. And literally, wherever it is that you start is the right answer. And once you start going into that, you now can say, I like this or I don't like this. And if you don't like it, that's okay. There's tons of other stuff to look at. And if you don't like anything in the consensus layer, there's a whole nother thing called the execution layer, which is talking about opcodes and precompiles and looking at code execution and malicious code execution vectors and security implications of how do you actually implement some of these things so that smart contracts are safe across all of the smart contracts in the database. Like, these are lots and lots, and I can't stress that enough. There is so much to know. All you need to do is bite off a little piece. And after you've bit off a little piece, you decide, this is wonderful. I could do this for the rest of my life. Great. You found your niche. Likely you may have to look through a couple though, and that's okay. Like, it's very okay to try. And then after you've tried it, maybe I'm going to look at something different. And in order to make that transition easier for you, I would absolutely suggest reaching out to some of the people on the teams. I happen to be a very, very talkative guy. Like, I love talking to people. We have a sync channel, like it's literally a voice channel on our Discord. And we just sit there while we're coding and we talk. And like, we love talking to people. Like, I know there are other teams that love talking to people too. And that's the best way. Like, if you're curious and you start to do internships with one of these Ethereum teams, talk to everybody. Now, I will say this, for those of you who haven't worked in tech before, we're all a little nerdy and some of us are a little uncomfortable talking. Not everybody's going to be as open or as like happy to talk as I am. That doesn't mean they don't want to talk to you. That just means they're not a talker. And like, there's this fine line. They say there's a fine line between genius and insanity. It's true. And like, the people in the Ethereum ecosystem are some of the most humbling, and it's like I'm humbled and invigorated every day that I come to work, because these are the brightest minds that I've ever imagined working with. It is shocking and appalling about how brilliant everybody is. Just human nature, like, we're all a little nerdy. I'm a little nerdy. We're all like, it's okay. It's okay. Just be open and honest. Go say hi. Some of them might not really like it, they're not being rude. They're a little awkward. That's okay. That's totally okay. And like, go talk to the next person on the team and just keep talking to people, and you're gonna find people you click with. Like, everybody, and I've met almost everybody on the core dev team because we get together pretty regularly, and they are wonderful. Like, the people who work in Ethereum are here because we believe. We love the idea of making the world a better place. We love the idea of building a brighter future. We love the idea of creating inclusion and comfortable spaces where everybody can be successful and we can make the world better. This is critically important, and it is amazingly cool. It's why I do what I do. And the most important thing you can do is just start. Go out, look at the specs. Like, I'm sure in talking about, like, preparing for this talk for you today, like, I know you're going to talk a lot about spec development and the EIP process, and you're going to talk a lot about the other execution clients. You're going to talk about a lot of the other things that happen when it comes to this process of making the transition into a core developer. And that's really the goal of what I'm very passionate about, because it's the journey that I made. Like, I was a construction manager. Like, I wore a hard hat and stood on site and like used to smoke cigarettes and yell at people for smoking cigarettes and yelling at people. It was very ironic. But like, I had a passion and I believed and I love this. And if you do too, you will fit in. That's all you need. And from there, you can now start to ask the question of, what am I interested in? What is an EIP? What are the different domains? And like, I've touched on them, but it's one of those things you're going to have to go back and actually read the spec and look at it. And then from there, you can start to nibble off on, I am really curious in the crypto. I want to see more about ZK, which is awesome. Like ZK is the future of everything. Like we're rebuilding the whole EVM in ZK, the ZK VM. And if that's what you have passion for, there's a ton of opportunities. And that has zero overlap with the networking stuff that I was talking about. It's just, I'm doing a lot of networking because I'm working on PeerDAS right now. So like a ton of the stuff I've been thinking about is the networking component. But like, there's so much of so many little facets. And like, and I apologize, I can't give you a good answer. Go pick this up. Like the answer is that's going to come from you. And finding someone that can help hold your hand and kind of show you the small little bits and pieces of where you can kind of find your resources, because obviously you can't do that in this forum. It's something that really you'll have to find a mentor. Or for me, I just was really passionate. I opened up the spec and I started reading it. Like it's very possible you could do that. And then from there, you will figure out, like, you'll find that you'll gravitate to reading some parts of the spec more closely than others. You'll be more interested in some things than others. And then that will give you the internal kind of like, not to use use a wonderful cliche, it will be your lodestar. Yes, I work on the lodestar team is the name of our client. That's just so now I've rambled a lot here. I've talked a little bit about the high level. I've talked a little bit about the details. And now we have about a half hour left. So if there's any questions, this is what I'd like to open up the floor. Come on, someone's got a question. I see a few of you writing.
Matthew, I can see you on X. The first thing I want is to connect with you on X.
I don't really use
I
it.
see you. No. Where are you most? How can we connect the most with you?
Okay, so the very best thing you can do is let me create a link right now, is Discord. So I'm on Discord. I work for a company called ChainSafe. The way that most development happens in the Ethereum ecosystem, like the developers work, or excuse me, the researchers work for the Ethereum Foundation, and then all the people that work on the client teams work for other companies. And many are nonprofits. We are a not-for-profit. We are profitable, but we're a not-for-profit. Primarily, we do protocol development. So I work for a company called ChainSafe. We have a Discord server. Our Discord server has a number of channels that pertain specifically to Lodestar, and that's really the best ways to find me and a lot of our team. So let me do that right now. I will post it for you guys, and then feel free to join our Discord, and yeah, be very happy to talk with you there. Okay, copied that, and okay, there it is. Let me know if you have any problems, or please just reach out to any of the coordinators. They'll be able to find me. We have a lot of direct connections, so feel free, if you need help, come on by. I am on X. I just avoid X. It's kind of a cesspool of bots and trolls. And to be fair, like the most important thing for me is not to follow the Twitterati and the Twitterverse. Like there's a lot of, pardon my French, there's a lot of bullshit on there. And like when it comes to really builders and passion, I try to, focus on the builders and passion. But great question. Feel free to come to our Discord. Next.
Hi, thank you for being here. My question is more like personal. Let's say I'm someone who is really shy and I'm from Colombia. Crypto is not very popular here. So I would like you to let me know, how can I start approaching people and start talking with people from the protocol and knowing how I can get better, because I would like to be a researcher someday.
Okay.
I know talking to people and it's like one of the best options, not only for learning, but also for being more active in the community. Thank you.
Yes, great question. It's a great question. So first off, I love Colombia. I will be there in October, just passing through. But and I'm passing through because I'm going to DevConnect. So the very best way that you can meet people, it's actually how I met the Lodestar team, was I was at DevCon in Bogota a few years ago. All right. So like there was a big conference. I went there. I happened to sit at lunch. I was talking to some people, and it just so happened the person I was talking to, because we're all there. Like all of the core developers, all the researchers, everybody who's consequential is there. And like, I literally just happened to be sitting next to Barnabas, who's one of the leads of the infrastructure team. And he's like, I've got somebody you should meet. And he literally brought me over to meet the Lodestar team. Like, that's an amazing way. Say hello. But This is a very unique, it happens once every 2 years. Dev Connect is going to be in Argentina. It's not always feasible for people to travel, to other countries to go to a conference. So like, I understand that that is not the best solution. It is a very good option though. If you have the opportunity, there are a few conferences where everybody goes to. Generally, DevCon or Dev Connect are once a year. They're generally in November. They're run by the Ethereum Foundation and everybody goes. Try to stay away from the ones that are mostly shill fest, meaning Token 2049. Well, actually, I don't want to say badly about anybody. Like, stick to the ones where it's builders only. Protocol Berg in Berlin is another one. Okay, so now, outside of just physically going to meet people, it is very hard to meet people in person. And this is why, is that I work on a team. I am in Bangkok. Tuyen is in Ho Chi Minh City. Nazar is in Berlin. Nico is in Madeira. Cayman is in Tennessee. Phil is in, you know what I mean? Like, we're all over the world. And it's very rare to bump into people. Like, that's very rare. So you have to go to where they are. And this is why I gave you my Discord. Like, it's where I am. I'm there every day. It's where I'm there for work. And all the client teams have that. As a matter of fact, the ETH R&D, let's see if I can get you the link for that one. The ETH R&D Discord is where everybody from Ethereum is. Like, it's where the, I don't know if I can give you a, all right, I'm going to send you this one. I'm not sure if it will work, but I'm hoping it does. Okay, so that's the Ethereum Research and Development Discord. This is where we do a lot of discussion when it comes to, like, I am on the ChainSafe Discord because that's my company. And Lodestar team is there. We're there all day, every day. It's where we talk. It's where we hang out. We sit in our sync channel. You'll see it's called Lodestar Voice or Lodestar Sync. It's a voice channel. Oftentimes we just sit in there. It's like the water cooler, and we'll hear us typing and we talk, and it's a great place to come find us. And same idea. I know Lighthouse has a Discord channel. I know Geth has, like, go find the Discord and go talk to them. Like, that is the very best way. And it's not in person. It's like a chat channel. So you just say hello, and you do have to put the work in. And I apologize if you're shy. That is a tough thing to get around. I know it is, but you just have to, because we are too. So, like, if it gives you any consolation, you're going to be talking to people who are also shy, and they're just like you. And, like, we all want to talk, and everybody wants to say hi. So don't be shy. Like, don't worry about it. Like, everybody's very kind and very polite and very nice. And really, that's the best way in order to be able to reach out to find us, because really we're online. And, like, to be fair, I go outside, but I go to the gym, and I go out. I go to the nightclubs and stuff like that. Like, I like to party, but at the same time, like, I don't want to talk about Ethereum when I'm out, at a nightclub. I want to dance. I want to party. You know what I'm saying? So, like, yes, you can find me there, but, like, come to the Discord. It's much better, and we'll be happy to talk.
Thank you. I appreciate it.
Very welcome. Yulia, you have your hand up.
Hey, hi, hello everyone. Well, first of all, Matthew, thank you so much for such an entertaining and insightful talk. Yeah, I'm sorry for not turning on my camera. I just got off 16 hours flight. So yeah.
Don't worry about it.
Yeah, I was like, to your point of like the importance of IRL events, I just had a chance myself to participate in a couple of them, like East Global Hackathon and Basecamp, and
Yes.
it was insanely valuable like experiences. Yeah, I really, guys, like everyone here, I really recommend you do so, like especially Dev Connect in Argentina, if you have a chance. Also, I know sometimes like traveling the world could be not as accessible as we wish, but just think of it as a kind of investment also. Well, I did it myself.
It really is.
Yeah.
It really is.
Just investment in your future in Web3. But yeah, my question, Matthew, yeah, sorry. Yeah, I've been working in data for like 10 years in Web2. So I'm like naturally interested more in data querying and indexing. So what would be the domain you would recommend me to start digging with?
Okay, so there are the Applied Research Group, and there are a number of other companies that do a lot of this stuff when it comes to data and indexing, and they're looking at chain effectiveness or outcomes when it comes to we're designing a new protocol or a new like PeerDAS, for instance, and what is the most amount of data we can push through this thing before we start to hit bottlenecks when it comes to networking or database design. And like this is kind of extra protocol. It's like outside of the protocol when it comes to like data aggregation and information related to the actual like chain effectiveness, or there is a lot of data analytics that we do as part of our day-to-day, at least for Lodestar. But it's performance metrics. Like we're looking at dashboards that have tons of, like we'll do instrumentation points in the code that we're collecting data as the thing runs in order to be able to display a dashboard that has the information that we need in order to be able to analyze it. So like there is a lot of data analysis that happens just in the functioning of a node. But as far as like looking at network data or data availability or effectiveness or what clients are people running, like are they running more Lodestar, are they running more Lighthouse? Like all of that stuff happens outside of the protocol because it's a domain of like some of the researchers look at this stuff, and matter of fact, a lot of the researchers look at this type of thing, but really it's more to tailor the actual protocols that they're implementing or specifying. You would like Sunnyside is the one that comes up. They've been doing a lot of stuff recently, but they're focused on how do the different clients stack up against each other in order to understand like how can we make the network work better as a whole, because obviously a chain is only as strong as its weakest link, and being able to improve performance across all of them matters. So not a great answer. I apologize. There is no real in protocol domain for doing that, but there is a lot of stuff that's kind of pertinent to it.
It's been great. Thank you so much. Yeah. What's the name of the company you mentioned recently?
Sunnyside Labs. They're out of South Korea. They're relatively small. I think there's only 3 or 4 or 5 people there. And I'm not exactly sure how their funding works, but they've been very helpful and they've been wonderful for us.
Perfect. Yeah. Yeah. Just to start looking around. Thank you.
Good luck. I think Lupe, I believe you were the next one.
Hi, Matthew. Yeah, I'm Lupe from Bolivia. I'll be at the Connection Argentina. So my background is a front end. I think I have been front end engineer for the last 5, 6, 7 years, and I am really deep into the roots of JavaScript. So I was wondering, like you mentioned that you were into JavaScript, but it was more like in how it's built, I think. So maybe it's not the same thing. So is there a specific place where I could contribute more, maybe with my current skills?
Okay, so there's a thing called client diversity. And what does that mean? Is that this consensus thing that I was talking about, the consensus algorithm, meaning how we send blocks and how we vote on what is the tip of the chain and how we do a lot of state transitions and all of that is implemented by 5 different teams. More than that, there's 5 official and there's a 6th one that actually happens. And these teams are Lighthouse, Prism, Teku, Nethermind, Nimbus, Lodestar, and Grandine. All right. And then why am I saying that? Is because Lighthouse is in Rust, Prism is in Go, is in Java, Nimbus is in Nim, and the important one, the one that I work for, Lodestar, is in TypeScript or JavaScript. And this is why I kind of joined them, is that I understand a lot of the internals of Node.js as a runtime. So I've done some contribution to Node. I understand a lot about how to plug native layer, because you can run anything that's C ABI compatible can be run by JavaScript runtime. So this is kind of like the idea of like all of our crypto libraries are written in C or in Rust. Our database is written in C++. A lot of our performance critical things are also written in a native layer, and then we export them to JavaScript and run them in JavaScript. It's kind of one of those niche things that in JavaScript, it's kind of like WebAssembly. All right, so why am I saying this? Is that there is no real front end when it comes to anything in blockchain. Like front end is not something that we do. All right, but Node.js is a server. Okay, and this is where we are the only JavaScript implementation. We are actively switching over to Zig, though. So JavaScript is incredibly important, but at the same time, as you know, it's a single-threaded runtime, and there are a lot of implications to using JavaScript as a multi-threaded application that can make it challenging in order to use. So it's one of those things that like we do. And honestly, if you want to come over, I've sent our Discord link. Come say hi. We've got tons and tons and tons of stuff. Like we can get you started on a good first issue. And then I'll be happy to show you around the code base and get you started if that's your language of choice. But why am I going through this? Because not so much of like you're a JavaScript person, but we might have Java people here, or we might have Rust people in the audience. And this is an important thing, is that there is a body of work to understand what a protocol is. Like, how do we do the different domains of the protocol, like we were talking about before? But those same protocols, the idea of our libp2p, our gossip sub, that is implemented in Rust. It's implemented in Java. It's implemented in C#. It's implemented in NIM. It's implemented in JavaScript. Like that same exact protocol is implemented in 5 different languages. So really, you need to understand what is gossip sub, but you also have to understand what is the language that I'm actually programming it in, because that's kind of an important thing. Like these are high level languages, or excuse me, the implication or the implementations of these protocols are done at a relatively high level in these languages, because obviously what we're doing is very complex, and being able to program through some of those challenges is something that is also going to be complicated. And so what I would suggest is doing it in the language that you're most comfortable with. So if you like JavaScript, come to Lodestar. We are a JavaScript client, so that the burden of understanding the language is much lower, and because you already know the language, and you only have to focus on some of the nuances that are specific to Lodestar alone. All right. And then if you're a Rust person, go work with Lighthouse or work with Grandine, because those are Rust implementations. So they're also going to be doing the gossip sub, but they're going to be doing gossip sub implemented in Rust. And this is a very important thing. For those of you who do not have any programming experience, there are lots of things that you can do that are not, that are not programming specific. They are much less than the ones that are programming specific, though, because obviously we're doing stuff that is programming based. But as I believe Yulia had brought up, I like data analytics. I'm curious of understanding what is the chain functionality, what is the efficacy of this new protocol that we're implementing. Like, this is another total domain that has nothing to do with programming, or if it does have to do with programming, it's very a limited programming scope. I will say though, honestly, programming is an important thing. Like, for most of the stuff that we're doing, programming is going to be an important thing. And if your goals are to get better with programming, this is a great way, by picking up some of these first issues, in order to be able to use that first issue, because most of the repos have what we actually have it as a label on some of our GitHub issues. And I would suggest GitHub is a great way to interact with people as well, by the way. So like, go to the repo, you'll see who the main contributors are. You'll be able to see who the current contributors are that are constantly doing PRs, and you'll know who you should reach out to. You could just say hello on a GitHub issue. I'm looking to contribute. How can I help? And it's a great way to reach out to people, by the way. And so now look at what language that thing is coded in, and that gives you a great opportunity in order to be able to learn that language through the process of contributing to one of these repos. I will say this though, honestly, it's an uphill battle. Like, I can tell you the Lodestar code base is the most complicated JavaScript code base I've ever worked in. It is by far it is a very large code base. We use very complicated programming paradigms, and most of the things we do are not cut and dry, because efficiency is very, very important. Like, being able to run these applications, they're very high performance applications where every single line of code matters, and being able to tailor every single line of code matters. So you will see some programming paradigms that are more complicated than are typically seen in a simple application. So don't let that dissuade you. If you are just getting started in programming, honestly, it's going to be an uphill battle, but it's one of those things that is rewarding. If you really have passion for it and you see this as a long-term future, you have to start somewhere. And with AI is really good as a teacher. So it will be a very good, useful tool in order to get you to that next level. But short answer is, if you're in JavaScript, come see us at Lodestar. We're the only JavaScript client, so like it makes it very easy. The next in line on my screen is, and I apologize for names, I'm very bad at this. I believe it's Nidhi.
Hello.
Hello.
Hi, Matthew. So this is my first class. I couldn't join due to some reasons. So I heard that you were not into tech background, right? That was really inspiring that you shifted to become a solid like developer, right? So what
Yes.
actually inspired you to become a developer to contribute to Ethereum? And
Ah,
also and I'm also starting I'm a developer, but I'm starting into developing like big I want to become a solidity dev and contribute to Ethereum ecosystem. So how
okay.
did your first few years journey towards Ethereum look like? Like
Sure.
I joined boot camps and all, but it doesn't go much farther. How did you sustain it? How did you learn? How did you get better? How was your journey?
Okay. So I did real estate development. I flipped some apartment buildings in the crash of 2008. And just because my dad was a carpenter, I like working with my hands, and I afforded myself some time off. And I was traveling for quite a long time. And honestly, I was a little bored. So my first career, like I said, was construction. But after sitting on a beach and traveling and going, having a lot of fun, I'm just not. That's not me. Like I'll work till the day I die. I love it. And so I found crypto. I had heard about crypto many, many years before. I had a friend who he was a programmer and he got started in Bitcoin in 2012, right at the beginning, 2011, 2012. And I do regret not like when he told me about it at first, I was like, you're freaking crazy. This is junk. Don't bother me. And he's like, no, it's really cool. And I'm like, okay, whatever. And so fast forward a couple years later, I found myself I don't know how I stumbled across it again. I apologize, I don't remember. It's a very long time ago now. And when I found it, I was like, aha, this is pretty interesting. I'd found it was really Bitcoin was really all there was at the time. And I started to understand the philosophical basis behind it. Like I really understood the sociological and anthropological applications of this technology. And it's a whole nother discussion I can go off on a tangent with. And I'd love to do a TED talk with you guys someday, but now's not the time. And so once I realized, I was like, wow, this Bitcoin stuff is amazing. How does it work? And I could not find any information. Like I talked to a bunch of people, nobody ever heard of it. It was like, so I asked my friend Chris, I was like, Chris, how do I read this myself? Like, how do I do it? And he basically pointed me to the repo on GitHub. And I literally started to look, like I opened up the repo and I was like, okay, where's the exe? I'm going to go open the exe and look at it because like I didn't know any better. I have no idea that that's compiled code. Okay, so like I opened the repo and I was like, what is this junk? I have no idea. And I was like, I have to know because I'm one of those people where if I don't see it in the proof is in the pudding, if I can't see it, touch it, understand it, I don't believe it. So I wanted to understand the code. So this is why I taught myself to program. I wanted to be able to read and understand how this worked because I wanted to be a contributor. I thought I would honestly be doing protocol development for Bitcoin, and I may end up still doing that at some point in the future. I do strongly believe in it. I know that's a very spicy topic in the Ethereum community. There's a lot of people who will literally we do lots and lots of talks about this, but at the same time, I'm very pro Bitcoin, but I'm also very pro Ethereum. And so now I spent several years teaching myself to program. Granted, I did not do it all at once. I was scuba diving, I was having fun, and then I would program for a couple months and I got a little frustrated and I was confused. I was like, I didn't know how to talk to anybody about it. And I would spend a few more months doing nothing. And then I would come back to it because I was like, okay, I really want to do this again. So I spent a couple years doing that, like start and stop, learning. And then I got my first job. So I got my first job was not crypto. To be fair, I went to a boot camp in order to get my job. So I went to a boot camp when I was in Miami, and I really they were great for like some of them are better at teaching, some of them are better at professional services, and that was really the one I went to. I chose one that has a great network, and they were able to get me a great first job. So I basically started working about halfway through the boot camp. Towards the end, not it was a couple weeks towards the end, and I got my first job, and I just started working with the guy. I was doing wallet development, meaning like Apple Pay and Google Pay. So there's an awful lot of crypto that's involved in how that stuff works. But really, it wasn't crypto. And then from there, I just spent several years working at different positions until I ended up at a crypto company. I met them at a buffet in New York City. I was walking down the street and there was free food. And I was like, ooh, free food. New York's expensive. So I was like, okay, like I like free food. And I walked in and it was a crypto company that was throwing this bash. And I was a programmer working, doing cloud migrations. And so they basically, I was talking to them. They're like, and I started working for them. They were doing NFTs at the time. It was all the rage. And then I went to DevCon because I was in the Web3 space. So I was able to kind of get my way down to DevCon, and that's how I met the Ethereum people. So I literally sat next to him at lunch. We were talking, and it just kind of happened from there. So like my journey was not a straight line. It took me a couple years in order to like learn how to code. But again, I wasn't doing it like my job. I did it like kind of as a hobby. And then it took me a couple more years working for other people only because I never really thought about doing protocol development. After a while, after I started programming, I was just happy to be working and doing something. And so I never really, it was like protocol development was an accident. I met the Ethereum guys as an accident. Life takes a little bit of luck and a lot of hard work. And that's one of those things I can't stress enough. Like you have to have the luck and you have to have the hard work, but the putting yourself out there and reaching out on Discord and putting yourself in the places where lucky things can happen, it definitely helps. And like that's one of those things. Like put yourself where the people are, and luck and lightning strikes. And then from there, you can hone your skills. And to be fair, you'll have to hone your skills in order to get to there also, because everybody work with is really smart and very hardworking. So like you can only bullshit so far. Pardon my French. Like you're gonna have to be able to like rubber hits the road. And when it comes down to it, like we are very accommodating and very open in order to help people develop their skills, because if we see people who are hungry and passionate and really care, that is all it takes. And then from there, all the hard work takes over. But the passion and putting yourself where lightning can strike really is an important piece. That was my journey. Okay, we've got 2 more minutes left. So you're the next on my screen.
Hello, good evening.
I apologize. You're
I'm currently working on this, contributing to this issue.
Your voice is breaking a bit.
I apologize.
Now, what about now?
It's still breaking. It's still breaking a bit. Maybe you can share your question.
Yeah, try typing it in the chat. We're gonna go to the next person, and then I promise we'll run over. Okay, please type your question in the bottom, and we're running out of time, but I'm going to take one more question.
Okay, can I give the last one to ask, please? My hand has been up for a while.
Sure, go ahead.
Okay, so from the start, first of all, I need to appreciate you. You made this so fun for me. Made me love it, like want to hug it more. So you talked about like everything went about 2 things: consensus layer and then the execution layer. And then you talked about going deep down and then trying to break everything down and start as small as you can while you keep growing at it. So my first question was, which layer do you think would be a bit friendly for someone starting out, consensus or the execution layer? And then secondly, I also have a background in Python and JavaScript. Apparently, I've done JavaScript, like, all those libraries. So I feel like, where do you think I would start with? Like, I was doing something with Python because those are the 2 backgrounds that I feel like I'm solid a bit. Like, on Web2, that was my background. So where do you think I would start with? Please, those are 2 questions in one.
Sure.
Yes.
Okay. So between execution layer and consensus layer, they're totally different. And again, this goes back to that discussion of which interests you more. I can't answer that question for you, but what I can say is definitely take a peek at what the execution layer does by looking at the execution specs. And then it's called I think it's just the execution spec. They are getting better with that. They're not as detailed as the consensus specs, are a little better. But take a look at both and see if you're more interested in doing the runtime application implications of the execution layer, or if you're more interested in consensus. And again, they're very different, and it's not something like I can tell you which is friendlier. Like the consensus specs are a little easier to read, but at the same time, like it's really like when you come to the programming of it's not it's they're about the same. Okay, and to answer your second question, Python is only in the spec. There is no Python client. Python is not performant enough as a language in order to be able to do any of the implementations for the clients. JavaScript, as I had mentioned to, I believe Lupe was the one. Lodestar is the only JavaScript client. Now we are actively switching over to Zig as a language. So we do an awful lot in JavaScript. We still are very, very active developing JavaScript. Well, it's TypeScript really, not JavaScript. But we're actively moving to more, just for performance reasons, Zig is a much more performant language. So really, like the best bet for you is like Python is not something that I would pursue, or at least for Ethereum programming. And I would look more towards like, feel free to come to our Discord. We can point you in the right direction for some JavaScript stuff. And then from there, we know a lot of other people on other teams. If there's other language that you're interested to dabble in, we can talk about that. And then for the last question now, I apologize. I know we're running over, but I did promise Paola I was going to answer her question is, what are the main reasons Lodestar was built with Node.js? As I read, it's limited, slow, kinda. And how did the team handle the whole limitation thing, especially for attestations? That is a fantastic question. And this is a very, very, like, there was at a time, there was an interest in order to do a lot of this stuff because Web 2 was really the thing at the time when this really started. And being able to run a lot of this code in the browser was something we thought would happen. And so Lodestar was built partially because the libraries, in order to be able to do what we do, so like a library for SSZ, the library for BLS and all the crypto, all of that is isomorphic. It runs in the browser, it runs on servers. And we do that specifically because a lot of the websites that run Ethereum application pertinent, meaning the validator sign up web page is something that the Ethereum Foundation hosts, and that uses the libraries that we built because we build in JavaScript. But it has its limitations when it comes to performance. Like that is obviously it's a single thread and it's a multi-threaded application. So there are real challenges, and JavaScript is one of those languages where it's very easy when you start. So like the learning curve is like you can get very far and it doesn't get much harder. But then when you get to the very end, you get this really steep curve. And this is why I'm telling you that the Lodestar code base is fairly complicated. We use all of the most complicated programming paradigms where complexity is not something that we are concerned with, performance is. And in order to be able to do the stuff that we do, because there is a lot of work that a node has to do, meaning a lot of memory that gets moved around, and there's a lot of CPU time that is just inherent in order to be able to run this application. It's very processor intensive, and Node.js is not the fastest runtime. So like lots of things that we have learned over the years are strictly around how we do this. Like we pre-allocate data and then use a cycle buffer in order to be able to do a lot of our hashing. Or when we make API calls is another thing. Like we're calling data back from the execution layer. This is one of the optimizations we just did for PeerDAS is you call in order to get all the blobs of data. They come across because it's a JSON RPC. So like all the data comes across the wire from the execution as JSON. The bottleneck is not the network traffic because it's all on loopback. It's all running on the same server. Like the bottleneck is literally turning the string that we get into a binary buffer, like binary data, and being able to allocate that binary data, which is very, very slow when you don't know how long the data is in JavaScript. So like what we have to do is what JavaScript will do is it will read the string into a buffer, and then as that buffer grows, it will read it into a larger buffer and like basically do copies and copies and copies. So we had to pre-allocate a buffer big enough because we knew what it was, and then we would read into that buffer so that you don't move the data. And like it's just a nuance of what we do. It's something that like the team that makes Lodestar is, I don't want to toot our own horn, but we're some of the best JavaScript developers I've ever met. Like we are like, and I'm humbled and invigorated to just be on the team. Like they are some of the brightest and best developers I have ever had the privilege of just being able to watch them do what they do. They are amazing. And it is one of those things that is just, it's our bread and butter. We know JavaScript deeply and intimately. We implement it in a way that is incredibly performant, and we do so because we need to. And the only reason why we know that is because we have the metrics and the telemetry in order to be able to tell us that like that's where our bottleneck is. So it's not a straight answer. It's just we do it. Okay, I apologize. We're running over. We're 8 minutes over. So thank you. Welcome. If I haven't gotten a chance to get to your questions, please, can we do one more? She's got her hand up. She asked pretty please. Can we do one more?
Yeah. We don't have any restrictions on time.
Okay.
Yeah, if it's fine with you, if it's not getting late for you, we can take it up.
Okay, so we'll do the last question. This is the last question though. I apologize. So Ebinola?
Yes, Ebonloa. Hi. Good evening,
Hi.
everybody. I apologize. I can't turn on my camera right now. I'm in a dark place.
Don't worry.
So I've been enjoying this session. This is the very first session I really enjoyed because I also have a background in Node.js. And I think it's the only, server-side language I really got into when I started my tech journey. And earlier, some days ago or some weeks ago, I heard that JavaScript is not really welcomed in Ethereum and all of that. So I was a bit discouraged and tried to like learn other stuff. But thankfully, this is really, really interesting. So what I really want to know is, what is your everyday tasks like? For instance, you've talked a lot about your journey, you've talked a lot about what you guys do, but I want to know what your day-to-day is like. What kind of problems do you solve on a daily basis? Do you have like a project that you run for an extended period and then complete it, or you just have like tasks that you complete? Can you just take us through what you really achieve, even if I don't understand it? Thank you.
That is, sorry to cut you off, but I want to make sure we have time, and I know some people have to leave. So that question is not specific to JavaScript. It's kind of how most of the teams work from what I've seen. And it does feel very similar to how our team works, is that we all kind of work independently together. It's a kind of a unique thing because everybody that works on all of the core developers are very accomplished and very motivated. Like it's one of the few places in the world I've ever worked where you don't have to tell people to work. Like they want to be there. They're there because they believe and they care. And there is no like taskmaster standing over you that's like, you do this, where is that thing? Are you done yet? Like, because we don't need that. Like it's one of those things, like we're all actively working together, separately though. And what do I mean by working separately together is that usually the teams are anywhere from 7 to 12 people. And then there's going to be fork n+1 and fork n+2. And what do I mean by that? The current fork that Ethereum is on, it's the current upgrade or the current version is Electra, or at least from our side, the consensus side is Electra, but Pectra, because Prague was the Ethereum fork name. Okay, so like we're on Pectra version right now, and we're going to be doing Fulu coming up. All right, so the next one is n+1 is Fulu, and then n+2 is going to be GLOASS, and don't ask me what that stands for, but I think that's the mix of two things. And Fulu, I don't know where they came up with that one either. They're very creative names. I don't know. I don't make those. That's beyond my pay grade. I was working on n+1, meaning I was working on Fulu. Like I was working on the PureDAS version of the PureDAS protocol, or EIP. So like the next fork that's coming up, and that is the one that's going live in a couple months. We're going through testnet development. We actually just caught our release today, actually, and we're going to be putting that through testnets in the next month or two, and that will go live in December. And then the next one is going to be GLOASS. The GLOASS is we're upgrading. It's called EPBS. It's Enshrined Proposer Builder Separation. We're going to be doing block level access lists is the other feature, the major headline feature that's going into the n+2 fork. And so Why am I saying this? Is that there is a significant body of work. The other thing we did for Electra is Fulu is blob schedules. So like BPO forks. So like the two main features that go into the next network upgrade is going to be blob schedules and PeerDAS. And then the ones that are going into N+2, the one that happens next year, is going to be EPBS and block level access lists. So these are EIPs. You'll talk a lot about what the EIPs are and how the specs get derived from the EIPs. And then what the client teams do is we implement, actually program the feature. Like we're the ones who actually build this feature after it's been specified by the researchers, and actually the core developers. We do a fair amount of the spec development as well. And so now we have a number of people on our team. I was working on PeerDAS. Nico was working on the blob schedules. And then we've got a few other people on our team that are working on, like I had mentioned, we're in the process of doing a code transition from using a lot of JavaScript to using more and more Zig. Zig is just a different language. It's a relatively new language, but it's a very high performant, close to the meta language. It's very similar to C or Rust. And so we're in the process of rewriting a lot of our code in Zig, because when we get to the H fork, which is the one that's N+3 right now, so it's in 3 network upgrades, we believe that it may even happen before that we are going to be running Zig as a language. So we are in the process of, we have some of our team that's building out those features. We have a couple people that are doing unit testing and doing a lot of cleanup and making sure that like all of our dependencies are up to date. We don't have security vulnerabilities when it comes to that stuff. They're doing a lot of things like there are some very deeply difficult debugging tasks. Like we were getting an end of line input is one in particular. So Nazar was working on this. He's a very detail oriented, extremely good debugger. And he has deep knowledge about a lot of different things. And so we were getting these weird errors in our command line. And like when we were running nodes in our DevNet, and he was the one who figured out what it was. What it was is Nimbus execution layer, which is the EL, was like there is disk v4 and disk v5, and disk v4 was used discovery version 4 versus discovery version 5. All right, was being used by Nimbus EL, and they decided that they were going to switch to using disk v5 because they can choose which one they want, and they're a relatively new product. So they were using disk v5, and when they were doing that, they were connecting to consensus nodes, not just execution layer nodes. So like they were trying to do an execution layer handshake with our consensus node, and basically our node was basically canceling it. We were turning them away. And so this is a great example of how do we do these segregations of work, is that we all kind of have what we like. We all kind of know what needs to happen. When we see a body of work come up, we kind of raise our hand and say, I think I'm going to do that thing. And then we do it. And then we work together separately. So we're all kind of working on these different pieces of the protocol. We're working on different domains within the client. We're working on different types of implementations. And then all of that comes together as a coherent whole when we get together every week on stand-up, when we say what we were talking about. And then we'll usually say, I've hit a roadblock. I don't know how to do this thing. And we'll talk about it. And somebody else will stand up and say, I'm a domain expert with that. Let's step in, and they'll give you a hand. So it's very, very free-flowing, very wonderful work environment. But in order for it to be successful, you definitely need motivated, eager, excited people. Hopefully that answered your question. Okay, that really is the end, because I have somebody waiting for me. So wonderful. Thank you so much for coming. Yes, I am. I'm at my standing desk.
Everyone enjoyed it.
Okay. So thank you. Come find me on Discord, and I'll be happy to talk more.
Bye, everyone.
Good luck, everybody.